Hello, everyone. My name is Taryn Wells. Thank you for being a part of the Hawaii Department of Transportation's 2024 Protect Our Water Conference. I will be your moderator for this morning's session titled The Replacement of Makaha Bridges 3 and 3A. At the end of the presentation, the speakers will have a few minutes to answer your questions. So without further ado, I would like to introduce our speakers for this session. Ben Garde is a licensed civil engineer who received his Bachelor of Science from the University of Illinois, specializing in structures and construction. He has spent his career at the Bureau of Bridges and Structures within the Illinois Department of Transportation, retiring in 2011 after 33 years. Currently, he is employed with QRSE, having started with them in 2020. As a construction manager, he ensures all day-to-day operations are meeting all requirements of the design plans and special provisions for construction projects on behalf of the Hawaii Department of Transportation. Chord Medeiros is a civil engineer with a growing role in the construction industry. Since graduating from the University of Hawaii at Manoa, he has become an essential team member at QRSE. His leadership in training and implementing e-construction software for HDOT has been pivotal. Chord oversees software transitions, data migrations, and onboarding while managing website resources and refining best practices for HDOT e-construction initiatives. As a field engineer, he applies his knowledge of HDOT specifications and project planning with a focus on quality control, contributing to QRSE's standards of excellence. Please help me in welcoming Ben Garde and Chord Medeiros.
Okay, hello everyone. I'm Chord, and along with me is Ben, and today we're going to be talking about the replacement of Makaha Bridges 3 and 3A. So before we get into the bones of the presentation, just wanted to go over a brief outline of what we're going to be presenting today. We're going to first go over a brief project background of the project, the existing structures that were there before construction started, and also the new design of the bridges. And also the assembly and placement of those trusses for the bridges. The next topic is the work area conditions. So we're going to go a little bit over of heavy rain events that went on during the project. And then we're also going to go over the types of BMPs utilized on this project, both temporary and also permanent BMPs. And then the last topic we're going to go over is the environmental obstacles and issues that we had to deal with throughout the project, what happened, how we mitigated them, and how we moved forward with the project. So with that, Ben's going to be going over the project background.
Aloha, or back in Illinois, it'd be hello. So the location of the project is on the very far west end of Oahu in Makaha, and it's like the furthest outpost of the island. It's pretty nice. The scenery is great. And I would like to show you a video of the project from an aerial point of view. As you can see, we're heading towards Kaiana Point. And the first bridge below right there is Bridge 3. And we're heading north. And then to the right is Keeley Drive. And then as we move forward, you can see Bridge 3A up there. And that's the limits, probably another 500 feet past that is the limits of the project. And I think the drone will go down and show you the cross section. As you can see, these are relatively old bridges. Everything's made out of wood. Okay, just want a little brief background on the bridges. The Bridge 3 has 3 spans. Bridge 3A has 4. And the superstructure is comprised of wood plank deck on wood beams. And the substructure is composed of concrete abutments and wood and cap columns for the piers. As you can see, this is Bridge 3. The decks and the beams and the piers and abutments are all deteriorated. The bridge width, as you can see on the left, is inadequate, doesn't have any shoulders. And the railing is wood and it's not crash worthiness, so that's a safety problem. And it's also restricted on loading. It's certain restricted vehicles or trucks can only cross that. And if you're overloaded, you have to get a permit, which is a big thing to get. So moving on, you could see that we had to strengthen the piers below so we could take traffic. Same thing with Bridge 3A. Now the new design is on a similar alignment, but this time we're going to use a prefabricated truss, and there'll be a single span, about 100 feet for Bridge 3 and 130 feet for Bridge 3A. And improvements will be, it'll be able to carry any type of load, current load, have hydraulic opening, it'd be wide enough so when the storm hits, the water won't back up, and then it'll provide shoulders and a walkway. Yeah, just briefly, I know this is a water conference, but I'd like to just go over a little bit of the construction of the truss. This truss was used or pushed, or not pushed, but asked for because it's never been done previously. Normally, when they launch trusses, it's along the longitudinal, but this one was built on the side and pushed across because of traffic concerns. You can't stage or contraflow a truss bridge. So this is a picture of them assembling the bridge. This is a picture of backhoe, and if you look underneath the concrete areas, there are rollers there, and so the truss is pushed across. And then finally we push it across, and the truss is sitting at its temporary location. And so for both bridges, we had a 3-day weekend to do all the work. Bridge 3A, we had to close the traffic, and we had to provide access for the community north. And so they had to take shuttles to the bridge, walk across the bridge, and then go to their car. And so beginning at 8 a.m. Friday, we demolished the existing bridge, which is no longer there. And then the portion of the truss had its deck on there to allow the vehicles to cross while we were working on the bridge. And then once it was demolished and it was ready on Sunday at 8 o'clock, traffic was then closed again, and the bridge was placed in its permanent location. And after 11 o'clock, traffic was reopened for emergency vehicles only, and the pedestrians was allowed to cross. Okay, real quickly, this is a picture of what the bridge looked like after. If you look at on the left, the bridge was slid across, and you can see the temporary lane there for the vehicles, emergency vehicles, and then while the contractor built the other half of the bridge. And then they were supposed to be done by 8, and they had little problems, but we were able to open it by 10 o'clock that evening. And this is what it looked like on Monday morning. As you notice, we had to keep temporary barriers on there because of the zone guard barrier on the bridge was not on there yet, so we had to provide some kind of a barrier. So with that, I'm going to have Cord talk about the work area conditions.
Okay, thank you, Ben. So if there are any other questions about the assembly and the structure type of the bridges, there will be time at the end of the presentation to ask that. But now we're going to be getting into BMPs and work area conditions. So just wanted to briefly show you a flow diagram, if you will, of how the water flows when there's a heavy rain event. So as you can see, it's a little bit small, but if you could see the two bridges, and also there are two streams in the work area, the Makaha stream and the West Makaha stream. And water flows directly towards Farrington Highway and goes underneath both bridges. But the neat thing is the Makaha stream will take a right turn and kind of go towards the West Makaha stream, as you can see in the diagram above here, and it'll flow out towards the beach, towards the very end, past the two bridges. So this is what typically will happen during a rain event, and just wanted to show you a little picture as well as some pictures of this. So this is kind of the conditions that we had to deal with throughout the project when a heavy rain event occurred, or if there was high surf levels. But you could see that the water level almost reached the bottom of the bridge deck, and the water level is very high. It's hard to work in these types of conditions, but that is why we formulate and create SWIP plans to address this and account for these types of events. And moreover, there's some more pictures. So that was on the Makaha side, and now we're going to go take a look at some pictures of the Makaha side, where it'll run through the bridges, around the streams, and out towards the beach. So now that we've seen some pictures, we're going to go over some types of BMPs that we utilize to combat this and to protect the water, as it is the theme of this conference here today. So the first BMP I wanted to go over is perimeter control. And there are three main types of perimeter control that were utilized on this project. The first is composite filt sock, and the second is silt fence. I'm going to go over the third in the next slide. But those are the two main ones. And as you can see on the slide here, there are cuts from the field manual, as were typical BMPs for filter sock and also silt fence. And for biosocks, the main purpose is to reduce flow velocity and to retain sediment and other pollutants that run through the biosock. Similarly, for silt fence, it is stakes with permeable fabric wrapped around it, and the purpose is to intercept and slow the stormwater that has sediment in it. Now, one of the challenges we had at the Makaha project was the Makaha beach right next to the project area was very heavily frequented by beachgoers and the population. And through this, we would go home on a weekend, and then it's a very busy weekend, and a lot of the BMPs would be run over. Specifically, a lot of biosocks would get run over, silt fence would be ripped down. So we found ourselves constantly replenishing these types of BMPs, but it's important because we do not want any sediment to get out of the project area. We want to contain the sediment so that we can capture it and we can clean it before it gets outside to the project area. So that was one of the main issues we had with perimeter control on the Makaha project. And moreover, you can see there are pictures here. There are pictures here, and the main goal was for the silt fence was to wrap the entire project perimeter with silt fence, and then for the biosock is to line it along the streams, line it along the embankments, as you can see in this picture on the right, lined it along the top of the embankment so that when water went through it, it'll reduce the flow velocity and it'll also capture sediment before it goes down the sloped embankment. So that was the main purpose, that was the main goal, to have biosock along embankments and also along the streams, and also silt fence along the entire perimeter of the project. Then the final form of perimeter control that we had on this project is check dams. And there was two designated locations. The first one was under Bridge 3 in the Makaha stream, and the second one was the West Makaha stream under Bridge 3A. And as you can see again, there is a cut from the field manual of what a typical stone check dam looks like. And on the next slide, I'll show you what it looked like for Makaha. But the main purpose of this is to, number one, reduce erosion, number two, slow the velocity of water, and also number three, similarly to the prior perimeter control, is to catch sediment. And these check dams were in the stream. So as you can take a look on the right, you have the check dam for Bridge 3, and on the left for Bridge 3A. Moving on, we have stockpiles. Now, this is a typical BMP for all projects, or for most projects. And if you're going to store material on project site, you are going to need to cover and surround it with perimeter control. And this is of the utmost importance when you are near bodies of water, and we are near ocean and also two streams. So this was very important, and we had to make sure that all the various material that was used on the Makaha project was properly covered and surrounded by perimeter control, because this reduces the potential for air and water pollution. I mean, if you think about it, there's water around the project site, and if you have very fine aggregate on your project and you're storing it in a stockpile, if it's not covered, then the wind can take it away, heavy rain can wash it, and if it goes into the water, that's not a good thing, right? The theme of this presentation, protect our water, keep it clean. So Makaha had various amounts of different work. There was asphalt work when building Farrington Highway, Keeley Drive, temporary access road. And then there was also a lot of aggregate work with the embankments and the channel work underneath the bridges. And then additionally, there was concrete work, right, with the abutments and the channel slabs, the slope walls. All of that concrete work required rebar. So we had to rack and cover rebar as well when it came to material storage. So this is, again, wanted to emphasize this because this is a BMP that can be utilized across all projects, and especially if you're near bodies of water, right? So next we have hydroseeding and mulching. Makaha had a good amount of embankment work alongside Farrington Highway and also along the streams. So one of the main points of focus after disturbing the ground is to revegetate, to promote vegetation. So what we would do is we would use hydroseed. And as you can see on the bottom picture, that is when the embankment, the north side of Bridge 3A, Malka side, was hydroseeded, and also the contractor set up irrigation so that water can be dispersed at different times throughout the day. And the main purpose of hydroseeding is to protect bare soil, to protect the exposed soil, and to increase infiltration, especially when, the soil is exposed. And if you look at the top picture, this is what the embankment looks like now. It has a lot of vegetation. It looks green. It almost looks better than when before construction started, right? So that's the goal. So yeah, that's hydroseeding, and this can be utilized, again, on various different projects across the state. Okay, now getting into our permanent BMPs. Wanted to emphasize this because this is part of the project, one of the bigger ticket items, which is riprap. And riprap is large, irregular sized rocks that we placed along the embankments of both streams, under Makaha Stream under Bridge 3 and the West Makaha Stream under Bridge 3A. And now what this did was it stabilized the slopes of the embankments and slopes of the stream, and it protects the soil surface. And then finally, it slows the velocity of runoff. And as you can see in the pictures that I showed earlier, when there's heavy rain, the rain will come down the embankments. And the point of this riprap is to reduce the velocity of that and to catch also any sediment that may come along with it. But the main point is during heavy rain events, water is gushing through these streams, especially Bridge 3, because if you take a look at some of the pictures, Bridge 3A underneath our West Makaha Stream, it kind of acts like more as a lake where the water is a little bit more stagnant, but under Bridge 3, water gushes and flows through that stream. So that's going to be getting into my next BMP that I'm going to be talking about. But the first permanent BMP is a riprap. And the second one is the channel slab. So on the side here, you can see there is a cut of riprap from the field manual. But in this case, under Bridge 3, since there is so much water flowing during heavy rain events and high surf, HDOT ultimately decided to to install a channel slab and slope wall. And what this does is it essentially mimics riprap, but at the same time, it has better erosion protection and prevents from bridge scour. And it essentially has the same purpose, so it'll protect from erosion, it protects the soil surface, and it also stabilizes the slope along the embankments of the bridge. And this one is directly underneath Bridge 3. So as you can see, there's pictures here. And next, we're going to talk about the environmental obstacles that we had to go through for Makaha. So I'm going to hand it back to Ben.
One of the requirements for this project was to provide biological monitoring and archaeological monitoring. The biologists worked daily from 6:45 to 12:15, and they were required to be there every working day. This project had a numerous amount of endangered species: the Hawaiian bat, Hawaiian stilt, the hanu, and the Hawaiian monk seal. I think we only just maybe saw a couple hanus and a monk seal, but overall there wasn't any problem. Archaeologist was present during any excavation, and no EV was unearthed during this project, but they did find a gun and a wallet, and so that was very interesting. Moving on, you always hope that your project will run smooth and cleanly and don't have to worry about any having to follow up on reports or anything, but as usual, all projects aren't that way. And we had our share. We had to do we had discharge issues regarding water valve leak, groundwater discharge, and dewatering pits. This is the first discharge. It occurred in December of 2022. As you could see, we were, this was March of 23. If you could notice, we had to excavate for a water line, and in order to excavate, we had to dewater the excavation, so there was a pump installed, and the pump brought the hose all the way out to a grassy area where the water would go into the earth. And then that was done for a long time because it took a while to excavate. But anyway, what happened was the area got inundated, too much water, and then the water didn't have anywhere to go, but it ended up at the last arrow going into Makaha Stream. So at that point, the project excavation was stopped. We installed biosocks to help stop the leakage, and then the contractor got together with his designer, and they decided to put a earth embankment dam that's about 2 feet high. So here's the picture. This is where they're excavating. As you can see, the hose and the pump, and then it's taking us south and into the hoses into the ground. And then this is the area after the inundation, the water started going into Makaha Stream. So on the other side of the silt fence, that's where the area was. We ended up putting biosocks right away, stopping the project. And in the meantime, they decided to put this earth embankment. As you could see, it went around the whole area, and it was monitored daily by the contractor to make sure that there was no overflow. Moving on to SWIP, this project had a lot of phases, so it required a lot of amendments, 30 in all. What we would do, we would start, and then every time there was a different work stage, we would do the amendment for the SWIP and so forth. This one's an example of SWIP 19. This is the part where we had the discharge, and we ended up updating the SWIP to show that the earth berm. Some of the things that are addressed up there, I know it's hard to read, but here, the items we addressed in SWIPs were our stockpiles, spoil piles, construction entries and exits, drill shaft work, assembly of the trusses, because the trusses had to be built on the side, installation of micropiles for utility poles, which was a last-minute thing, so they had to dig, and we had to provide embankments for them to get down there. Ramp access, so every time that we had to do stream work, we had to provide entrances into the stream. And also when we removed the bridge, they had to have access to the stream. We had water line excavation, demolition of the bridge, concrete washout areas, make sure that the concrete doesn't flow out. And then when we did drill shafts, there was a slurry mix that had to be contained, and so they brought in frac tanks. We had a large amount of frac tanks for the slurry mix to go in, and also water from excavating the water line after the CLSM was poured had to be put in frac tanks too, and then treated. So in addition to frac tanks, we used discharge pits and grassy areas. Okay, now that the next item was a dewatering pit. What happened was we had to do a channel slab underneath that Cord was talking about, the channel slab. We had to dig for the cutoff wall. The cutoff wall is about a 1 foot by 4 foot section on both sides of the channel slab. And in order to build that, you had to excavate probably a 5 foot wide area. And when they did that, of course, the groundwater came up. And in order for them to form, you had to get rid of the water. So GP, Great Pacific, decided to use a discharge pit to solve the problem. As you can see, the backside there, they're developing the pit. Here, they provided the liner. And this is the area where the cutoff wall is. If you look at the gentleman there to their left, that's a 4 foot wide or 6 foot wide hole full of water, and you can see where the hose is down there in the pump. And then after it's pumped out, the laborers were able to get in and form the concrete, the forms. And this is showing you another view of the hose going up and into the pit. Our next discharge occurred up there on Bridge 3A. My notes. Naturally occurring groundwater from the trenching for, the highway, Farrington Highway on the Makaha side, north of Bridge 3A. They were doing drill shaft work, and one of the equipment went across the road to be set aside, and they ran over a steel plate that had a valve covering over it. Well, when they ran over that, the valve cover broke and the water started running. And then next thing you know, it was flowing down next to the abutment and down into the stream. BWS was informed, and they came back, and they brought their crew to repair the valve. But in the meantime, the water kept coming down, so we had to put biosocks. This area wasn't worked on yet, so there wasn't any biosocks available at the time because it was not being used. So here's the leak. And you could see it's coming down on the side. We put biosocks trying to stop. There it is, reaching the stream of West Makaha Stream. And eventually, it just kept running because it took them a while to stop the leak. So in the meantime, we provided more biosocks at the stream. In particular, the biosock on the right, that was to protect water from moving towards the Mulavai, which is a saltwater area pond. And then finally, we have hazardous material. We counted hazardous material at one time. It was on the West Makaha Stream at Bridge 3A. It was an oily type substance, not related to construction work. It was the supervised consultant, environmental consultant inclusion, took the lead on finding a remediation and providing a report to HER. And the contact was the HERE office. And then they submitted a report and the solution to getting rid of the oily substance. And the solution was to deploy petroleum pads, sorbent pads. As you can see here, that's the project engineer in the morning kind of walking the site, and he noticed the shiny substance there towards the middle. He contacted me, and I contacted Inclusion. They came out after discussing with HERE, and they provided these absorbent pads. And as you could see, after that, they just put the rocks. And he came out to monitor at least 3 or 4 days to make sure everything was finished. And so there was no problem. He submitted the report to HERE, and we never heard anything back, so I assume it was okay. So today, we are completed the project, and we're in the process of doing the punch list. And as you could see, too bad I don't have the existing picture next to it, but as you could see now, the bridge is on a better alignment. You got shoulders on the side for people to be able to walk. And that was bridge 3A, and this is bridge 3. Similar structure, similar cross-section. And here's what it looks like on bridge 3 looking towards Makaha. And this is bridge 3A looking towards Makaha. As you could tell the difference, this is more like a lake where you don't really have much water flowing hard. That's why there's no concrete slab. While here, there's a concrete slab because this is where the water flows from the mountain downward. So I think that's the presentation. I'd like to just thank some people. I want to thank my crew, Danilo, Cabalang, Lincoln, Tejada, and Chord Medeiros, and from Bowers, Nestor Guib and Jay Stone, who did the QA, QC for the SWIPs. And HDOT, I'd like to thanks to Daryl Tanabe, the current RE, Willie Rapasura, the former RE who retired, and Scott Watanabe, the lead inspector, and third-party inspectors, Claudia Ackroyd and Angie McAdingding. Thank you for keeping us on our toes. And for Grace Pacific, Eric Hansen, Scott Peterson, and Zach Alcos. Last but not least, I want to thank Kai Kraut, the owner, who lured me out of retirement to work on this great project. Thank you.
Thank you, Ben and Chord, for your presentation. We're now going to open it up to Q&A. If anybody has a question, please raise your hand, and we will bring the microphone around to you.
Aloha, my name is Colin from Wesley Arcegawa, and I just wanted to ask you guys to maybe go through or talk about how you guys came up with the process of determining your BMPs, and if you guys were meeting just the minimum required from the state, or you guys proposed additional ones just based on your judgment. And it seems like others may have came up too during construction, so maybe if you can talk about that a little more.
So, yeah, as Court said, we provided the required BMPs that are required for the project and in the beginning. But as the project moved forward, there was unknowns because you got different things going on, drill shafts or whatever else. And at that time, that's when prior to that start of that work, we decided to, provide the proper BMPs. It's really hard to tell what you were going to come up with, but yeah.
Any other questions? All right, then we will go ahead and close this presentation. Thank you both so much. Please hang on. We'll announce the winners of our raffle at the end of this. So thank you for all attending the Hawaii Department of Transportation's 2024 Protect Our Water Conference. Please be sure to fill out the post-construction survey that will be emailed to you after the conference ends to receive your Professional Development Hours certificate. As a reminder, speaker presentations will be posted on the Stormwater Hawaii YouTube channel, and presentation slides will be found on the Designers and Contractors tab on stormwaterhawaii.com following the conference. And the winners of our raffle gift baskets are Sherry Suehiro from Bowers and Kubota and Melissa Sterlacci from SSFM. If you've won, please pick up your gift baskets at the check-in desk. Thank you so much.
Thank you.